Welcome to a new episode of Technoculture. I'm your host, Federica Bressan, and today my guest is Marc Leman, research professor in systematic musicology at Ghent University in Belgium and director of IPEM, the Institute for Psychoacoustics and Electronic Music. Currently, Marc is also head of the Department of Art History, Musicology and Theatre Studies at Ghent University. Welcome, Marc.
Thank you.
Your name is mostly associated with the concept of embodiment. Your seminal book, Embodied Music Cognition and Mediation Technology, published by MIT Press a little over a decade ago, introduced this concept of embodiment into the field of systematic musicology. What is this concept, briefly, and most of all, what are the consequences of bringing this concept into the field of musicology, and what was going on before you wrote that book?
Before, we mainly had attention for the perception of music, and we thought that we could understand meaning formation, musical meaning formation, by means of perception only. And before that, it was even score-based research that we did in musicology. But at a certain moment, I realized that perception was not enough, and we connected action to perception. This was also a trend in cognitive science, and developed a concept, or let's say a paradigm concept, because it was designed as being a new paradigm for music research, for understanding how people make sense of music. It was designed for that reason. And so the role of the human body is actually that you couple your perception to your actions, to, let's say, a repertoire of actions, like I am moving my hand now. That's a repertoire of automated actions, gestures, which are in my mind or in my body, in my brain. And so when you listen to music, you couple it to that repertoire of gestures. And due to that fact, you already know much better what will be the next step of what you perceive. What you will perceive next step is actually guided by your body, because the body contains a lot of information about prediction. How we predict the world around us is fundamentally inside our action schemes.
You said that the concept of embodiment was already present in the cognitive sciences, in philosophy. You didn't define it from scratch. So when you embraced that concept and had the intuition of bringing it into the field of musicology, did you adapt it? Did you bring your own interpretation of embodiment, or you stayed true to some possible authentic meaning of embodiment?
Yeah, that was very much an own approach of adopting the concept of embodiment. Actually, we spoke more about gestures in music. We spoke about it already quite a long time. But the term embodiment comes from studies in cognitive science, and we brought it into the musicological domain in relationship to gestures. How people move, how they move their hands, how they move the body when they sing or when they listen to music.
This is not just for people who make music, but also for the listeners.
Exactly. It's also the listener in the same way as the maker, as the musician. The listener takes in the sound, and in the brain, sound is connected with the body, and it's through the body that the listener makes sense of music.
Now, what does technology have to do with all of this? Technology as the extension of the human body. What does it change in the observation of people making music or people listening to music, people engaging with music?
With technology, and actually the technology that became available, let's say, in the 21st century, it became much easier to follow what the body does. Before that time, we could use a video recording, but then you had to precisely annotate. It was very time-consuming, the gestures. And now with sensors, with cameras that can detect movement, you can simplify it and you can easily gather knowledge about body movements. And so that knowledge with the new processing software could be more easily brought into relationship with sound. So we could make a connection really between the gestures as movements over time and sounds, which are in fact also movements over time. So we brought those two types of movements in connection with each other.
From what you just said, I get a definition of technology as a measuring device.
In that case, it is a measuring device, but of course, when you can use it as a measurement device, you can also use it as a synthesis device. You can move your hand in space, and if you can track that movement, you can connect it with a synthesizer. And you can turn parameters of your movement with parameters of the synthesizer. For example, the height of your hand, you can relate it to pitch. So the higher you go, the higher the pitch goes, and the synthesizer will create the pitch according to how you move your hand. And in fact, if you think about it, a musician, it's the same thing. You also have to move in order to create sound. On the violin, you have to move your fingers on the strings in order to change the pitch. On the piano, you also have to move your fingers. So you move and then you get the sound. This is the natural causality that is in the music.
Speaking of movement, you've also done some studies on dance. Dancing is also how we engage with music. Can you talk a little bit about one of the most interesting studies or most interesting findings?
Dancing, it's like listening, is not just moving to the music, but is playing with the music in a sense that you take a position where you can invent new things that are in contrast with the music or that go along with the music. And it is this kind of interaction that brings you meaning, that gives you meaning. So also very often dancing follows the beat of the music, and you move in a particular way according to the timing patterns in the music. But as a dancer, you are not the slave of the music, but you are in an equal position so that you can dance a little bit just before something is going to happen in the music or just after something is going to happen. So you can, what we call in music, counterpoint is actually doing the inverse of what you hear or going along with it. It's that kind of play that people use to make sense out of music.
You've just mentioned a very important keyword, meaning, because it sounds so far that what we can do now is measure things that we could not measure before. But we also have to make sense of these new measurements. We need to come up with a whole new theory. Can you talk a little bit about some new concepts involved there?
Well, what we measure is the surface of what people actually do when they give sense to music. And so it's only a very tiny part of what is actually going on. And so for that reason, we would also like to measure physiological changes like temperature or heartbeat or maybe even brain activity. We can measure that, but all what you measure is just a surface parameter of what is actually going on inside the head and the body of the person that makes sense of the environment. And so we have developed techniques that somehow relate these measured parameters with what we call the hidden variable inside the person. And that hidden variable is actually the thing that makes sense in this world. So it's a rather complicated type of research because it's very hard to find this what we call latent variable that is behind what you can see. But if you think about it, it is what we do all the time as humans. When we interact with another person, instead of with music, with another person, we also see only the things that we look at, so that we get as visual information, that we hear, maybe that we can feel. But in order to go deeper into the person, we have to form a hypothesis of what is behind these things that you perceive. And it is this question, what is behind, that we as humans are trained in since we are very young. And so we are actually very good at it. And we try to replicate that with computational methods. That's all we do, in fact.
Music is notoriously a very subjective experience. Everyone has their own preferred genre. Everyone has their own taste and approach to music. So after you've measured all the things you need to measure, how do you reconciliate this subjectivity with a general theory or with a description of a normal behavior, which is the expected output of a scientific study?
Well, the idea is, of course, that there is a kind of, let's say, global variability, that there are certain limits of what people can do. But I believe that every person is, in the end, very different from another person. So if you go into the fine details of how people differ from each other, they do indeed differ from each other. Does it mean that you can't develop or even study in a scientific way these persons? Yes, you can study that, and you can develop tools that are, let's say, taken into account the individual variability among the people. But of course, there will always be limits. There is a limit to our perception. There is a limit to our movements. And so this gives you the, let's say, the big container. But inside that, you have many different distinctions.
Over the years, your work has had interesting application domains, from medical rehabilitation to sports to education and learning. So in these domains, again, how do you conciliate a normal behavior with each subject's subjectivity? That is, if you observe how fine-tuning some parameters of a certain music impact someone's running style, can you then say, all right, if we change this music so and so, this other subject will show the same effects?
Yes, exactly. That is what we do. But we see, of course, also differences between people that have particular diseases and those that don't have this disease. But in any case, if you want a system that works, and my interest is indeed in biofeedback and systems, so applications of our research on musical meaning formation in biofeedback applications. If you do biofeedback, like we do in sports or in the medical sector with medical rehabilitation, you have to develop a technology that works for that single person with those particular characteristics and features. And so this technology is also developed for the individual.
Focusing on your studies with running, how music impacts running, and specifically with the application called D-Jogger, can you talk a little bit about the results? Were they unexpected sometimes, surprising, or they confirmed your expectations?
Yeah, D-Jogger is an example of how we could combine our understanding of how people interact with music and how we can manipulate people with it. Manipulation means, in a positive sense, to the benefit of the person, that we change the behavior of the person slightly, so to speak, with music. D-Jogger is a good example of my idea of music-based biofeedback. D-Jogger is the technology that aligns music with your own movement. So it aligns the rhythm of the music with the rhythm of your body. And when this alignment occurs, when there is an alignment, people like that, because if there is no alignment, it disturbs you. And so you like to be in synchrony with music. And that fits with the whole theory of embodiment, actually. So that gives sense to you, to your interaction. But of course we can, because we work with a music system that is a machine, a robot, so to speak, we can slightly manipulate how it interacts with a human, and that will slightly change the behavior of the human. So we can change the phase of the music. That's a tiny little milliseconds in advance or slower. And so with that, we can speed up a runner a little bit or slow down the runner. That's the kind of manipulations that we can do.
Without the runner noticing.
Without the runner noticing. So it's a subliminal level. That means sub-threshold. There is a threshold of your consciousness, and it is below that threshold of consciousness that you get manipulated, so to speak, and that you adapt your behavior. Why do you adapt your behavior? This is an interesting question. Well, you adapt your behavior because the brain always wants to predict in advance what is going to happen. And if you change what is going to happen, your brain will adapt its prediction even without your consciousness.
The feeling of being aligned with music is rewarding. We like it, and therefore we are motivated to seek that alignment. And motivation and reward are two important keywords in one of your last books, The Expressive Moment, How Interaction with Music Shapes Human Empowerment, published by MIT Press in 2016. Can you talk a little bit about these two concepts, motivation and reward, in relation to people's engagement with music?
Yes. We use reward in particular applications in running in a domain that is close to medicine, actually, where we do prevention of injuries that are caused by bad running styles. And so we measure at the tibia, we place a sensor that measures the impact of G-forces on the knee. And we connect with those G-forces a reward that is music. But when that force is too high and it causes you injuries, we put noise onto the music. And rather than being a reward, it becomes a negative reward or a punishment, so to speak. So we have reward, people like music. We have punishment, people don't like music with the noise on top of it. And so when they run and they hear noise, they try to avoid it by adapting their behavior. And then when they do it in a correct way, they suddenly hear, nice music, and they get rewarded. And that play of punishment and reward is central in what we call reinforcement learning. It is a kind of manipulating also people in a learning process by reward and punishment. That's what people do with little children when they have to train them, or with dogs also. They get the reward or punishment and then they learn the correct behavior. And that's a very powerful device that we have there that works with music. It's really very powerful because I can really bring down the dangerous forces that give you these injuries. It can bring them down. And we have a large study going on now for the moment. And we hope that when you relearn your behavior, that it stays for a long time in the relearned phase. So now it's a device that has the possibility to retrain and relearn people's habits. And this is an example of a music-based biofeedback system. I think it's the most successful example that is currently existing, as far as I know.
Among the other electrophysiological signals that you can detect now at IPEM with the IPEM equipment, we have skin conductivity, heartbeat rate, and also brain waves. Am I correct that IPEM has recently acquired a brain scan machine?
Yes, it's currently we have EEG and FNIRS.
Yes, so the whole IPEM in recent years has included the neurosciences more and more among the other disciplines involved in this precisely multidisciplinary center that is IPEM. And I would like to ask you how you conciliate a neurocentric approach of observing the brain functions with a fundamentally embodied approach. It seems to me that observing how the brain works may shift the focus back to an abstract level that is a disembodied way of conceptualizing processes.
Yes, what we see in many neuroscience centers that study music is that very often the methodology indeed prevents you to move. if you have to lay in a scanner for an fMRI study or something, you lay in the scanner and you don't move. In fact, your head is fixated so that you cannot move. But in our case, we want to bring in particular methods that allow a little bit of movement or a lot of movement even. So we will start up studies with EEG and movement. And the fNIRS is also possible to do that with movement. So I would not like to prevent people from moving because, this is our topic. We study the embodiment, and so we try to use those methods on top of them. But if it doesn't work with music, I would not like to, let's say, to do only the brain studies. There are enough and better centers for doing that than we can do it. But the combination of particular brain methods and movement, this I think is rather new in neuroscience.
And all of this, the new studies, the new equipment, is happening in also a new environment. IPEM has moved to a new building, a brand new building, about 2 years ago, joining other research groups and startups. So this building is a special place. It's called the Krook, and it also houses the public library of the city of Ghent. So it brings many elements together. Can you talk a little bit about how this changes the game for IPEM? What is this new ecosystem in which research is embedded? What is this new experience all about?
Yes, so the new experience is interaction, I think. We were able to think, let's say, starting from 2007, I started thinking about a new laboratory that would have its focus on embodiment and interaction. And now we are 2019, but 2 years ago, in 2017, this lab was actually available in a new building. And since 2017, we installed all the equipment, and the major equipment which we have for the moment is 3D audio, so it's for spatial audio rendering. We have motion caption cameras, 16 motion caption cameras that are perfectly synced up to sub-millisecond with the audio system. And on top of that, we can plug in the brain devices that then are perfectly synced with the entire system. And we can, of course, add several other sensors. And we even use virtual reality glasses and things like that. So we have this brand new and high-level lab since recently, and that opens up many new possibilities. And actually what I do is starting from the D-Jogger. That was an interactive kind of system working with only one parameter because we are extracting movement of a leg. Instead of one parameter, we expanded here to multiple parameters of the multimedia environment. But the idea is always the same, that we try to capture, through interaction, we capture the parameters that are related to sense giving, to musical meaning formation. And with those parameters, when we can capture them, we can include them in a biofeedback system. And now with the biofeedback system, now we can use 3D sound, we can use light, we can use projectors, we can use the entire visual, virtual reality, etc., etc. We have a lot more possibilities. So instead of a simple interacting device like D-Jogger, it becomes a very complex interacting device with other humans and with a modern media, actually. Yeah, with the digital, with the technoculture, so to speak.
It's all about technoculture. Besides being a research professor and scholar, you're also a musician yourself. You play the trumpet, you're an accomplished trumpet player, and you train regularly, and you also perform. So how does this direct engagement with music inform your ideas about music, or has it ever informed some choice you've made as a scholar? Has it given you insight in some particular phenomena you were investigating?
I think through playing music, I experienced that when you do that, you get quite easily in a kind of flow, what we call state of consciousness that is different from the normal state of consciousness when you speak with somebody. Or so it's a kind of trance that you, at least I get immediately in that level when I practice trumpet. And so I learned from that, I just learned why does it happen? And this is actually very fundamental in my research question. If we give meaning to music, okay, you have your bodily engagement, but that bodily engagement is also connected with your consciousness level that also becomes in a different state of being. And so my research question about embodiment and my most recent book is all about this. And perhaps it is grounded in this very fundamental individual experience with music as a musician. But I think I'm not the only one. I think most of the musicians that I talk with, they have this similar kind of experience.
Thank you for sharing your experience. It's been a pleasure to have you on Technoculture. Thank you so much for your time.
Thank you very much.
Thank you for listening to Technoculture. Check out more episodes at technoculture-podcast.com or visit our Facebook page at Technoculture Podcast and our Twitter account, #TechnoculturePodcast.